Section 2.3, describe the center of quantitative data. Our learning objectives for this section include calculating the mean and the median, being able to compare both the mean and the median, being able to understand what it means to be a resistant measure, and identifying the mode of a distribution. The mean is the average of a set of data values. To get the average or the mean, you're going to want to add up all of the data values in a data set, and then you're going to want to divide by the amount of values in that data set. So adding up all of the data values in a data set, that's going to be the sum of x. This sigma, capital Greek letter sigma, means to add or sum all of the little x values, and these are all of our little x values. We have 20 little x values here, 20 data values. So we would go through and we would add 0 plus 210 plus 260 plus 125 and so on and so forth. We would put those 20 values into our calculator, and when we do that we would get 3710. And then since we have 20 data values here, we would divide that by 20. Our mean of these data values would be 185.5. The mean is also the center of mass. So if we think of these data values as having some weight associated with them, and then we look at them on a scale, if we put the fulcrum of that scale at 185.5, it would be completely balanced because this is the center of mass for the data set. The median of a data set is the exact middle value or the midpoint of that data when you order the data from least to greatest. So in order to find the median for a data set, if we have an odd number of data values, it's going to be the number that's exactly in the middle. And then if we have an even number of data values, it turns out that there is no number that's exactly in the middle, because you have half that are on the first end and half that are on the second, so you end up having to average the two middle data values when you have an even number of data values in your data set. So here, this first example, we have an odd number of data values. We already have them ordered from least to greatest conveniently, and we're going to select the exact middle data value since we have an odd number of data values. And so this 99 value then is our median. So we can just take this value in the exact middle, and that's going to be our median. And we see that if we've taken this value that's exactly in the middle, we have 4 data values before and 4 data values after, so it's exactly the central data value. With an even number of data values, we actually look at both of these observations that are in the center and we average them. So 99 plus 101, add those together and then divide by 2. Well, obviously that's just going to be equal to 100. And notice how these data values really are in the center because there are 4 data values before them and 4 data values after them. Whenever we have a perfectly symmetrical distribution, the mean and the median will be right there together, close to each other, in the center of the data set. And in these symmetrical distributions, the mean is actually preferred over the median because it considers all of the data values. Whenever you have a skewed distribution, the mean actually gets skewed more than the median, and it gets skewed with the data. So in this case, when the mean is skewed, we really prefer the median over the mean because the median is resistant to all of those really extreme data values. What is a resistant measure? What do we mean when we say that this measure is resistant and this measure is not? Well, the root word of resistant is, of course, resist, and so a resistant measure resists change. If we only add one very extreme data value into a data set, sometimes that will change the measure of center that we're using. So for example, if we look at this data set with its 7 values and we want to add a very extreme value, let's say we go all the way over here on the left and we add another data value, well, that's going to move this mean quite a bit over drastically in this direction because it's got to balance all of these balls. And this ball way over here, because of momentum, it's going to be really weighting a lot more than these others. So the mean's going to move a lot. The median's not going to move very much. It's going to move just a hair to right here between this ball and this ball. So the median is very resistant to outliers. It only moves a small bit whenever you have an extreme data value, whereas the mean is not resistant to outliers. We define mode to be the value that occurs most often, or it could be multiple values that occur most often. Because the mode occurs most often, the mode is also going to be that highest bar in a histogram, or if you look at a graph of the distribution, it will be that highest point in the distribution because it is the value that's most frequent. Most of the time when we're using the mode for categorical data, and the reason is we really can't use anything else for categorical data. The mean and the median don't make sense for categorical data because you're dealing with non-numerical sorts of things. You can't average those. You can't order them from least to greatest. The only thing you can do when you have data that's not numbers is you can count how frequent each of the data values are, and then the mode represents the most frequent, most popular data value, and we can measure that.